and I want to add my welcome to all of you for being here. Dr. Baker sends his regrets. As you might well imagine, college presidents don't just sit at desks in their offices. They're out and about, and he's with college and university presidents at some meeting somewhere that I don't even know. So it's my job to welcome you and our special guest this evening. Some of you may or may not know the Dalton Lecture Series is one of the premier lecture series that we have here at George Fox. John Dalton was a scientist. He's best known for his work in atomic theory, and he worked primarily at, now it's just escaped me. Where was he teaching? Dwight? What? You know everything. But he was a Quaker scientist, and so we've named this series after him. We've had distinguished scientists coming and lecturing with us and being with our students, which is a wonderful thing. Now, I'm going to read some of Dr. Morris's biography. Obviously, he has pages and pages, and I won't get into that. And then I had the privilege of spending some time with him this afternoon, or this morning, and I learned some things that are not in his CV, so we'll go over a few of those as well. So Dr. Morris is a professor of evolutionary paleontology at the University of Cambridge and a fellow at St. John's College. He was elected to the Royal Society in 1990. His principal academic interests are the Cambridge explosion and evolutionary convergence. He may get into some of that with you tonight. Currently, he's addressing the so-called evolutionary myths, such as mass extinctions, human uniquenesses, and extraterrestrials, with the aim of puncturing some holes in the ideas of received wisdom. He has traveled extensively and conducted fieldwork in China, Canada, Mongolia, Greenland, and Australia, and has won many, many awards throughout his academic life, including the Walcott Medal of the National Academy. He holds honorary degrees from the University of Uppsala and the University of Hull. He is an active and public outreach person in science, lecturing in many ways on television and in other venues. He was the Royal Institution of Christmas Lectures in 1996, so he's very versed in all of these things. When he's not doing science, he likes to read theology, and G.K. Chesterton is one of his favorite authors, as well as the Inklings. And so, being a man from Cambridge, that might be an easier thing to do than some of the rest of us, but he lives in the middle of that whole environment. Now, let me tell you some other things about Dr. Morris. He lives with his wife in Cambridge. He doesn't have a car. They ride their bicycles everywhere they want to go. That sounds idyllic, but maybe on a day like this it gets cold. I don't know. He has 2 children who have returned to Cambridge, and he's a grandfather, which is always a wonderful thing. So I asked him how he got interested in this field of study, and he said, well, as a boy, I loved fossils and old bones, and here I am today. So dreams do come true, from small boys' imaginations to real scientists' discoveries. So we're very pleased this evening to welcome Dr. Simon Conway Morris. So please welcome him with me. Thank you.
Okay, well, good evening. Could I, first of all, thank you very much for the invitation to come and talk to you, and especially, and I hope I pronounce these names correctly and in the right order, Veta and Carlisle, and just Fred now talking today. I've been in your country many, many times, but it's always a pleasure to be back, and in this particular part of the world, which I don't know quite so well. So my theme, my plan, my aim this evening is to completely unhinge you. I'll see what we can do. So the first thing I thought I should do, because obviously being a wealthy academic in Cambridge, I have a series of country houses. And I thought I'd show you this one here. That's one. The access is a bit difficult, but we are taking bookings for next year if you're interested in anything. Now, the other thing I need to explain very quickly is that I have been invited to tell you a little bit about evolution. But I think you all agree that choice is terribly important. So I have taken the precaution of bringing some alternative talks in case they are of more interest. And I think we can do it by a show of hands. So first of all, who would be interested in, yes, indeed. Thank you, very good. Yes, not as many as I expected. The critical 2 years, a narrow gauge issue, you remember, that's right. The signalling problems, that's right, precisely so. A specialist area, but even one of, I think, absorbing interest. Now, I'm also sure that it's true that in this university, and heaven help us everywhere else, what in my country we call health and safety is of paramount importance. But are you aware that even now, in places, health and safety is not being properly observed? And this seems to be an area which is overdue for a proper lecture. And of course, I draw attention to the important area of high altitude ironing. I mean, look, honestly, look at it. No high visibility jacket, no safety harness. Just ridiculous. You know, and I can see you're shocked, and so you should be. You must write to your senator. The last of the alternative talks is one which I think actually will resonate with this country almost as much as my country, but that is the deep and impenetrable story of Labrador metaphysics. Look at that wet nose. What's going on in that head? Absolutely nothing. But I'll come back to that in due course. Or indeed what I've been asked to talk about, which is, again, I think this can only be above some Midwest state, but in any event, what evolution might and might not tell us about who we are and where we think we belong, and all the rest of it. Now, I'm fully aware, of course, that this is a profoundly Christian community. I'm sure not universally so, but very much as an area of received faith. And this may not please you all, and so too, if there's time for questions, I'm very happy to try and unpack this. But from my perspective as a natural scientist in Cambridge, Darwin got it right, okay? That's, you know, a most extraordinary man. I'm not saying he got everything right. I'm not making any extravagant claims, but the facts of evolution, from my perspective, are unassailably correct. We're still working in the area, but nevertheless. And I think this is exemplified very nicely by, well, this is a PBS thing, as you can see, but Neil Shubin, who's a very distinguished professor in Chicago, wrote a book called You're in a Fish. It's a terrific read, and I very much recommend it. And in essence, what he's pointing out is that throughout the whole of our frame, not only our bones, but down to our proteins in all respects, we have the whole stamp of evolution which permeates our bodies. We are products of evolution. And he's a particular expert on how these early sarcopterygian fish, relatives of the lungfish, came onto land. And there's dramatic evidence in the fossil record for exactly that. So that's fine and large. And these are the sorts of things which I also work on. On the other hand, when we begin to unpack things a little bit more, it becomes more complex, more interesting, and also more controversial. Now, many of you will be able to identify this as the Natural History Museum in South Kensington, London. It's no accident that it looks suspiciously like a cathedral, Romanesque, I grant you, and if they'd had a bit more courage, they no doubt would have had a tympanum here with Darwin passing on the news to everybody else, and all the saints of science on either side. And amongst the people who are enthroned within the Natural History Museum, and there are many there, of course, is this person here, Thomas Henry Huxley. who of course has been referred to as Darwin's bulldog. He was the great defender of Darwin. And I like this picture for many reasons. Again, it reminds us of the Romanesque architecture. I'm sorry, if I was a really good lecturer like you chaps are, I'd have 2 of these pointers and I'd be able to do it like that, you know, show how to button, you know, heck. I'm not a good enough. I like this also because what other society has so lost self-confidence, got to put a no smoking sign now, God, you know. Get a life, get a life. So in any sense, Huxley himself was adamant that there was a secular agenda which Darwinian evolution underpinned, and is all part of a very large debate about the role of any sort of creator in the perceived universe. And we all know where we're going in these areas. Again, I don't need to spend a lot of time about that. But of course, the fact of the matter is that so far as the explanation of evolution to the general public has been concerned, this has very much been inherited by a number of extremely vocal people. They include this individual here. This is Richard Dawkins. Not one of his, doesn't look particularly happy there, does he? No, what the heck? And so on and so forth. But there are further ramifications to this, and I must be careful. I'm not making specific claims that if one subscribes to evolution, then one is doomed to sort of perdition or anything else. But the fact of the matter is that there are metaphysics of understanding which may well give you a world picture which is not necessarily helpful. Let me briefly explain. Amongst the sort of contemporaries of Huxley, or slightly later, there was this chap here, Ernst Haeckel. And he's a very distinguished German anatomist, an extremely gifted artist, and was really sort of Darwin's representative on Earth, or at least in Germany. And he's sort of manically enthusiastic about Haeckel. But the fact of the matter is, and again, do not misunderstand me, I'm not saying that because you subscribe to this, you become this. But there are aspects about Haeckel's thinking, especially in terms of sort of racial theory and the like, which were extremely unhealthy. And I think one has to be slightly careful, again, but if we take one of the thoughts from this hideous man, Bormann, here, and I'm not going to try and translate this or even speak in a German accent, but unfortunately this earth is not a fairyland, nein, but a struggle for life, perfectly natural and therefore extremely harsh. And here we see the 1939 Nuremberg rally. Now, being a Darwinian does not turn you into a Nazi, let me make that absolutely clear. But the fact of the matter remains that if indeed you see a world picture which in a certain sense alienates you, then you need not necessarily be surprised that in a farrago of misunderstanding, these things can be adopted by relatively sinister forces. Oh, do you not want? Oh, there we are. Now, the other aspect about that, which in a sense at first sight looks relatively benign, is that from the perspective of evolution, we are utterly, utterly insignificant. And I like to refer to this as being analogous to what is referred to as Copernican mediocrity. Copernicus, illustrated here in present-day Poland, at that stage didn't quite exist in that form, pointed out that at the time he understood astronomy, that we ourselves are of utter insignificance, one tiny planet on one large galaxy in an almost infinity of universes. And correspondingly, you can claim that we are also, if you like, victims of a Darwinian mediocrity. And so it is that if you see the tree of life here, it's almost invisible to me, let alone to you. Unless at some of these talks, I asked my staff to put out opera glasses. Did they do it today? I'm so sorry. Typical. I'm so really are so idle. That red box, you are there. No, that's not humans. That's animals, and all these other groups. Those of you who are specialists on eukaryotes will see many other familiar groups here. But again, you can see from the perspective of Huxley, Haeckel, Dawkins, that we are just one insignificant twig on this enormous arborescence, this tree of life, as it's often referred to. So how could we possibly matter? Well, one could say in parenthesis, and this is actually non-trivial, that of course we are the only species which understands that. But from the other perspectives, and I think, I'm not again saying that Darwinian evolution is alienated. There are many, many factors at work here, and many of them go much deeper than Darwin. And I needn't go into all the details, they'll be probably familiar to you. But there is a sense of sort of existential uncertainty about our place in the universe, our place so far as we are anything at all. And that's a fact of life. Connected to this is the conviction that to the first approximation, evolution is pretty well random. And at first sight, this seems entirely reasonable. After all, mutations, which might be a cosmic ray, perhaps, or mass extinctions, all these things which ostensibly reset the agendas. And so they do, though not quite in the way you might expect. And this has been exemplified by Stephen Jay Gould, who, of course, extremely distinguished professor in Harvard. And I expect it's legible from where you are, but just briefly, wind back the tape of life to the early days of the Burgess Shale, the thing I've done some work on. Let it play again, and the chance of anything like ourselves evolving is incredibly small. And the argument for this, again, is very widely accepted by evolutionary biologists. And it is that although life itself has a very deep origin, and although for the best part of Earth history it's predominantly microbial, by the time we get to the Cambrian explosion, we have this extraordinary variety of interesting and strange forms here, some of which I talked about this afternoon. And then he would go on to say, well, how likely is it that from these starting points we would end up with a blue whale or a gorilla or this chap in his underwear here, that's you, by the way, or me, that's a human. So many of the twists and turns of history that the likelihood of anything like ourselves evolving is vanishingly small. And that is something which is very widely accepted, but I don't think, in fact, as it turns out, that it's really the correct perception on it. And the reason for this is that there is arguably a predictability to evolution. But on the other hand, this trope of rerunning the tape of life is deeply interesting, and it's something which also appeals to historians. And so we have these counterfactuals where we're invited to think about how history might have gone differently. And this is actually very, very slightly relevant to what's happening in my country at the moment, to do with the Brexit vote. And here I go, publicly, yes, I voted Brexit. No, I'm very naughty. Oh, no, all that independence, can't bear it. Here's a reconstruction, because Halifax became the Prime Minister, not Churchill. We capitulated, and the RAF put up a feeble show, and we have the victory parade of the Führer, April the 1st, 1941. I remember it vividly. And everybody in this is English, think on it. And in this particular book, and I mentioned this to some of the students at lunchtime, amongst the essays in it, because it's edited by Robert Cowley, was this particular one which inquired what would have happened in AD 33 if this man here, Greek-speaking but Roman, you won't have heard him, Pilate's the name, addresses this man here, who you probably have heard of. This is Jesus, of course, of Nazareth. And he looks at the crowd and says, oh, I can't bear this. These people are so utterly boring. Turns back to Jesus and says very quietly, you're free. And then even more quietly, and the very best of luck. How would have history unraveled? It would have been utterly different. Or would it? Because in point of fact, I highly recommend you read this chapter. It's very, very interesting indeed. But one is haunted by this idea that there might have been alternatives to the history we know. And this is indeed thought to be the case for the history of life. So, being in America, it is necessary that I engage in endless self-publicity and self-promotion. And here I am in front of you. And I draw your attention to my two masterworks, both very unfavorably reviewed. This one here, as you can probably, it's called Life Solution. Now, why call it that? Well, the fact of the matter is that I was obviously anxious that sales were high, and I thought with a title like that, it will end up on the self-help shelves. You know, oh yes, I'm taking out, crystals, tarot cards, all that sort of stuff. And more recently, this one here, if you say that quite quickly, it actually says ruins of evolution rather than ruins of evolution. But these two collectively are trying to make an argument that what we call evolutionary convergence does confer at least some degree of predictability on the processes of evolution, but paradoxically, we seem to be completely alone, which is ridiculous. That can't be right. Can it? First of all, let me very quickly introduce the concept of convergent evolution. Examples of convergence are found all the way from the molecular to the behavior. Now, I am aware, and I'm not sure I should necessarily be showing this slide, I am aware that this campus is dry. I'm very much hoping after my talk I will be in somewhere which is not dry. But for all of those of you, I was very amused when I was on a plane coming down, they say, would anybody like a glass of wine? Of course, up goes my hand like that, goes without saying. As long as you're over 21, I'd forgotten that. So all of you who are younger than 21, this is a bottle of extremely strong lemonade, okay? So you just you remember that. And the question here is, how does, and again, those of you under 21 will just have to ask your parents later, but, you know, What is the similarity between the way that we become intoxicated, or to use the English, sloshed, plastered, etc., and fruit flies? And it turns out that the behavior is remarkably similar. In the case of the fruit flies, you can't ask them, are you feeling all right? Do you want to go into the outside? All this sort of stuff. You measure how fast they're moving, and you have an extremely sophisticated piece of laboratory equipment known as an inebriometer. And this consists of about 500 cells, each one of which has a fruit fly in it. And the faster they walk, which is measured on the vertical axis here, then it is registered by them breaking an infrared beam. So bliss, the whole of the inebriometer is suffused with ethanol fumes. And see what happens. They immediately start rushing around like lunatics, all over the place. And then very quickly, only after about a minute, they slow right down. And this is more or less a time when, you've forgotten where the corkscrew is, all that sort of stuff, you can't find the waiters. And then they start to move more quickly again, but not quite as quickly as before. They plateau about here, and this is more or less the area where we find our own jokes intensely funny, our speech is slurred, the area. And in the case of the fruit flies, then they walk more and more slowly, and in about 20 minutes they die. But the point about this, and there are a whole set of other stories about alcoholism in fruit flies, which if I had time, I'd tell you about. The point about this is that actually this behavior is remarkably convergent on humans. So this is one to do with the behavior. Now, I could talk about molecular examples, and I'm going to go through this necessarily very quickly. But one of the most striking examples of convergence, which is one which is very well known, in fact, involves these two cats here. They're saber-toothed cats, as you can see. In this country, I don't have to tell you about this because you'll all know about the La Brea tar pits in LA, and is also found in many areas of Asia and Europe. This chap up here is also extinct, but occurs in South America. Now, those of you who are vertebrate paleontologists, I think they're about 40, yes? You can see that this skull structure is not identical to this, but overall they're strikingly similar. They're both mammals. That's fine. Now, the first one on the bottom, it belongs to the placental mammals. You're a placental mammal, at least I hope you are, and this means that you are very closely related, as is this cat, to the giraffe. Well, what about this cat up here? Well, you probably know how this story ends. That particular one is not a cat, it's a marsupial. In point of fact, it's much more closely related to a koala or to a wombat than it is to this cat here. But you can see that the convergence between these two cats is really very, very striking. In point of fact, in the literature, the adjectives used are almost ones of surprise. This is astonishing, uncanny, remarkable. But hang on a moment, this is adaptation. Grow up. But this is one hint of many others of the likelihood that the number of alternative solutions is relatively limited. Now, I'll just give you a couple of other examples, again, which are entirely classic. And these are important because they ultimately speak a little bit to intelligences and the like, and this is to do with sensory systems. So here we have a cuttlefish, and many of you, as biologists, will certainly know that the arrangement of its eye, the so-called camera eye, is strikingly similar to the eye of us humans. Evolutionary biologists, such as myself, will tell you this chap here is very closely related to an earthworm, and this may not please you, but you're very closely related to a starfish. So if you take a cross-section through these two eyes, specifically the ones which are illustrated here for the squid and relatives and ourselves here, the camera eye arrangement is astonishingly similar. Now, again, I don't have time to unpick all of this, but in point of fact, if you look very closely, the position of the retina, for example, is inverted in us and normal here. And this is extremely important because it shows that there's an evolutionary footprint which explains how they each came to much the same arrangement. But nevertheless, this camera-like eye has evolved, in point of fact, something like 7 times in total. And here's a marine annelid, which has very much the same arrangement. There's tons and tons of things I could tell you about this. It's a very remarkable example of convergence. But it's worth looking a little bit further afield, because, of course, there are many sorts of eyes. And amongst the alternatives is this well-known compound eye, which is characteristic of the insects. Now, the compound eye has also evolved multiple times. But you could also engage in a thought experiment, which is effectively to say, supposing for the sake of argument, the camera eye could not evolve. If we had to use a compound eye, would it be as good as a camera eye? Because after all, think about it. If you make the lenses too small, then they no longer act as waveguides. There's a limited number in the end of packing, both in terms of hexagonal close packing and the nature of a Euclidean space. And it turns out, in fact, that if indeed we humans had to have a compound eye rather than a camera eye, the size of the eye which we would be equipped with, would be, to put it mildly, disadvantageous. If I can get that. Sorry, come on. There we are. Yeah. We would need an enormous eye. It would be absolutely. In fact, this is a modest estimate. We need an eye about this wide across. That, to my way of thinking, suggests that if there are extraterrestrials of any description, what they're not going to have is compound eyes. There's empathy-free aliens coming down the ramp with their laser cannons with those compound eyes. Forget it. If they do that, then you don't have to worry. But they won't. They'll be coming to you with camera eyes, and you should be extremely frightened and run away as quickly as possible. So, sorry, I'm just trying to get the point to work. There we go. Now, all these stories of convergence could be unpacked in lots of different ways, but what I want to emphasize is something which I think is slightly underappreciated to begin with regards to evolution, and that is that evolution, by and large, is regarded as producing things which are good enough. They're not perfect. They're as good as they need to be. You don't waste energy on things which you might never need. It turns out, though, and do not misunderstand me, I'm not using this as some sort of cryptic way of bringing in intelligent design. Forget that completely. But it turns out that if you look at nervous systems, they're not very good. They're not very, very good. They are fantastically good. And here's just two examples, and I could give you many more. In terms of sound, not so much the bang of the sound barrier, but our ears don't hear as far as bats do, of course, but they hear down to the level of thermal noise, where molecules bang against it. You can't hear beyond that. In some ways, even more astonishingly, eyes can, in principle, detect a single photon. And if you tell a physicist this, they say, no, that can't happen. You say, no, I've seen it happen, yep. And similar arguments apply to electroreception and so on and so forth. What this means is two things. First of all, the sensitivity of these systems is incredible, but also, and I think slightly neglected, it shows that biology itself has reached the limits of the physical universe. So far as biology is concerned, you don't see beyond a photon, you don't see beyond Brownian motion. If you're a physicist, of course, you know about everything else. And that's another aspect about us, which is self-evident because we take it for granted. And in large part, not exclusively, it's his science which has opened our metaphorical eyes to this much, much larger universe. So that's one aside. The other one, which again could easily compile an entire lecture, is that my argument that something like a human is very like to evolve, has many strands to it and revolves around things as different as respiratory proteins, locomotion, grasping, but collectively, and again, those of you familiar with the area will realize I'm going across a complex area quite quickly. Nicky Clayton and colleagues in Cambridge have argued that if we look at the cognitive world of the scrub jay and the corvids and the parrots, to the first approximation, the experiments you might do, such as the string pulling or the observation of chimpanzees in Africa or their social systems, to the first approximation, although the brains of the bird are radically different from those of the mammals, they occupy very much the same cognitive universe. They are convergent. And this would be one hint that in that way, something like a human intelligence is very likely to evolve. Not frequently maybe, but it will happen often enough. It's happened 3 or 4 times on this planet, then out there it should be equally widespread. So in a certain sense, I now thank you very much for an interesting lecture. My taxes are thinking, I shall, oh no, wait a minute, one more slide. Fine and large. But this is when things become more interesting. Because in the last few years, looking at other people's papers principally, I've become increasingly interested in what it is which makes us so utterly different from all other animals. In other words, we don't doubt that animals are smart and do lots of clever things. That's beyond dispute. But what do they really know? What do they really understand? And here things turn out to be quite surprisingly interesting. Because Darwin explains to us, and this I do not dispute for a moment, of this evolutionary continuity, specifically between the great apes and ourselves. And so the argument is, very widely suggested, that there are at least nascent expressions of our cognitive capacity in animals. And that must be true, obviously. I mean, there are many aspects which have been documented in great detail, especially amongst the chimpanzees, but also in many other groups. And this, of course, can sometimes lead to a slightly regrettable anthropomorphism. And now I really want to begin to put a whole set of warning notes into position, because naturally we see the animal world through our eyes. And so the constant danger is we engage in anthropomorphism, or even worse, anthropocentrism. And this is a real problem. And animal behaviorists will, of course, insist quite rightly that animals have their own lives, which, so far as they're concerned, are perfectly satisfactory, if often dangerous. And there are many, many pitfalls in terms of understanding what animals can and cannot do. One of them is that there's the problem of what's called cueing, not what we English do so well, but the thing whereby when you give an indication to an animal, and the classic example of this, which appears in all the textbooks, is Clever Hans the horse, which seemed to be a bit of a wizard at mathematical calculations, until it was realized that in point of fact his owner here was giving almost invisible ticks and other cues to the horse to get it to arrive at the right answer. So people do their very best to make sure that in that sense the experiments which have been undertaken are blind, and they do their utmost to make sure that happens. But then when we start to look at this thing in a bit more detail, there's not a shadow of doubt that animals are intelligent and that they can learn. But one of the famous examples is to do with how dogs recognize names. And there are these incredible animals, those of you who know the literature, Chaser, Bailey, they're all there are. And some of these creatures can recognize up to 400 names, and you say, get Rhino, and there's a great pile of toys, and in goes a terrier, you know what dogs are like that, grabs it with his teeth, rushes back and gets a treat, quite right too. But in point of fact, you can show by rather clever experiments that the dog itself has no idea at all of the meaning of a name. In fact, its whole world, or our world, that dog is completely blind to. It's a sort of two tests thing. And it sounds a bit strange because you think, for goodness sake, you know, if it knows that thing's called Rhino, but there are a number of sophistications you can do to these experiments, which clearly indicate that the dog has no understanding of meaning. That name means nothing to it specifically. And again, do not misunderstand, I'm not denigrating what dogs can do, far from it. They're most extraordinary creatures. But it's natural for us to extrapolate our capacity for naming to these creatures, and it doesn't turn out to be valid. And one of the very interesting examples is to do, and this is an advantage from the point of view of convergence, is to look at intelligences which are not mammalian, and thereby are convergent. And amongst the superheroes in this area are the New Caledonian crows, and a number of you will know this famous experiment in Oxford. This is Betty, unfortunately now deceased, probably in Highgate Cemetery, I suppose, I don't know. In any case, Betty has been asked to retrieve a bucket of food in this recessed tube, but unhelpfully, her owner has only given her a straight wire. So Betty is seen futilely trying to use a straight wire to recover the bucket. No good. Betty jumps down against the edge of the tray, pushes the wire into a hook. Success ensues. And naturally, everybody in the laboratory bursts into applause. But it turns out, in fact, first of all, that in the natural world, this sort of hook bending is an innate property. What at first seemed to be a brilliant piece of joining the dots, in point of fact, was something which was much, much simpler. And this is even more dramatically shown in these experiments which use the Aesops Fable, which you will recall, of course, is the thirsty crow unable to retrieve the water, or wine in my case, from them, drops the pebbles in until the level is erased in the way Archimedes explained to us. And so you can do similar experiments in the laboratory here, and indeed they are dramatic. The crow learns to drop the material in, the water level rises and gets its treat. But again, you can make these experiments more sophisticated, and I'm covering a very, very large area indeed at the moment. But it now seems pretty clear that although these crows can certainly learn, although they certainly have intelligence, what they have not the foggiest notion of at all is cause and effect. They cannot join the dots. So when we would do these sort of experiments from quite a young age, we'd very quickly realize that bigger rocks raise the water more quickly. These crows do not get this. And you might step back and say, for goodness sake, these animals are not out there trying to perform Archimedes' experiments for us. But in point of fact, it now, from my perspective, seems quite likely that no animal understands cause and effect. And this is something which comes to us so naturally that we have a real effort to move out of that frame into, in a sense, an amental world. It's a real stretch. Now, I'm going to go through some other examples very quickly. If they come up in conversation or discussion or questions, I'll do my best to defend them. One of the unspoken secrets about this area is how long it takes to train animals as a whole. Now, dogs are peculiarly biddable. They're effectively symbiotic with us. But again and again, you'll find, in fact, when you read the small print, that in certain cases, quite frequently, I can think of several amongst the birds, it took 30,000 trials to even get a 70% success rate. And of course, part of the reason is you can't go up to them and say, well, Fred, old boy, would you mind going across there? But I'll explain why that's important in a moment. And there's one example to do with rhesus monkeys, where they're asking to anticipate the motion of a metronome. A year of constant experimentation, and they still didn't get it. And again, actually, this tells me something very interesting indeed. Not about the animals, about us. What other species have the patience to spend a year trying to tell a rhesus? Hats off, hats off. And very broadly, and again, I'm going through this rather quickly, but there is sort of evidence that what appears to be nascent capacities may not really be there. Animals don't have this ability to think out of the box. They don't have this ability to engage in what's called analogical reasoning. Yes, there are papers which claim they do, but they're not necessarily ones which are valid. And this is thank you. This is particularly apparent, for instance, from respect to tool making, because again, people say, for goodness sake, animals make tools. What's the problem? Well, there's no doubt they do use tools, such as this famous termite dipping. But what they never do is use one tool to make another tool. They might use two tools, but what they have is no inkling of is what we would call a cumulative technology. And I like to use this example here, which some of you may be familiar with. This is the amazing Antikythera mechanism recovered from an archaeological site, a sunken boat in the Mediterranean, probably built 100 AD. It's basically a Ptolemaic astronomical calculator, and investigations have shown the most fantastic gearing in it. And I show this really because it reminds us of the sophistication of ancient societies. And our capacity to make these tools is actually, oddly enough, that our tools are no longer tools. They are part of us. They are cognitive extensions of ourselves, which I don't think is the case with the animals. And this is can be quoted in various ways, but this one by Adorno here, humans are indissolubly linked with imitation. And that's something only we do. Lots of animals emulate, but they do not imitate, because we understand cause and effect. We can join the dots. We understand what the processes are involved, which allows us to repair a car in the old days. And other aspects of this, for instance, is, okay, cranes dance, but humans are extraordinarily good at mimicry. They're extraordinarily good at controlled movements. And there's a rather sinister example here, which seems to be going on in Europe once again, oh dear. And in the case of the ballet there, our ability to coordinate our movements, again, is because actually we can mind read. We can see into each other's minds, and we understand what the other person is doing. Some animals may have vestiges of it, but no more than that. And people then stand back and say, well, hang on a moment, we're so close to chimpanzees, and indeed we are, and don't they hunt? Yes, they do. These actually, I'm afraid, are not hunting. I couldn't find a photograph. I think they're all trying to get the same banana, but that's another story. But the point about these chimpanzees, when they do hunt, is that it's very impressive. They all go off. The males go. The girls don't go for various reasons. Don't like blood, perhaps. No. They can engage in ambushing and so forth. But it's clear again that they are acting as a pack of individuals. There is no plan there. There is no strategy there. And again, this is something we take so naturally. It's quite difficult, as I said already, to dig oneself out of this. And here's one thing which I'm afraid doing at the moment. No animal, with exception perhaps of an ant, teach. Animals can learn, But this capacity for ourselves to explain to the outside world, to read the audience, to make adjustments for the progress of the pupil, is something which is invisible to the animals. And then I hear a protest from the back. Yes, that's right. The representatives from the Meerkat Research Group are here. And they say, no, they teach. No, they don't. What they do is they instruct the young pups how to deal with scorpions. And clearly it's in their interests that they learn to use, first of all, a dead scorpion, then a defanged scorpion, so that ultimately, as adults, they can tackle a real thing. It's very impressive. They're highly social creatures. But it turns out that all of this is dependent on calls. And if you fox the pups by giving them the wrong, or the adult by giving the wrong pup call, then the adult will promptly reward the pup with death, or at least a very nasty sting. It's learning, but it is not teaching. And that even extends paradoxically to music. Yes, animals vocalize in that sense. They have music of the sort. But human music is extremely peculiar. And again, in a certain way, one of the advantages of being a scientist is actually trying to stand out of oneself and realize what a remarkable people we are. So human music is bizarre, not only because of its sociality and its link to dance, but also because it is completely meaningful, but means nothing. What on earth is our music for? There's been a lot of discussion about that. If you compare it to animal music is not monotone, but it's flat. It doesn't have these layers of complexity which we build into our music. And this applies also, of course, to mathematics. Many animals are capable of numerosity, the perception of different degrees of numbers, numerical distance, numerical magnitude. But no animal can count or subtract or divide, let alone think of a complex number. And do not misunderstand me. I'm not trying to denigrate animals. I'm not trying to say that because they don't have our capacity, they're not worthy of our affection or our love or our care. Absolutely not. No, absolutely not. If anything, the reverse. The very fact that we have what appears to be a privileged position gives us greater responsibilities. But the reason why this is so interesting, of course, is it revolves down to this very famous quote from Jean Vigner in Princeton, and it's being sort of summarized here in that quote, but is in the title of his famous essay, The Unreasonable Effectiveness of Mathematics. Why is mathematics so effective? Why does it work? Why do completely abstract things actually crystallize into realities? And his view, and I think of some but not all mathematicians, is in a certain sense, not only is mathematics fundamentally abstract, but we discover it rather than we actually invent it. This is a controversial area at all, but it's yet another hint that we are effectively accessing something which is very different indeed to what any other animal can achieve. And this comes home, I think, most powerfully, and this, I think, is a central point to do with language and the acquisition of words. Now, in this particular case, of course, a classic example are the vervet monkeys, which famously have three calls, one for a snake, one for a leopard, and one for an eagle. And as you can see in this particular case, the call sign didn't work too well. It turns out, and again, I'm very happy to unpack this, that it's not as simple as that at all. Different vervet monkeys behave in different ways in different parts of Africa. But more importantly, these words, so-called, do not convey meaning per se. That call does not mean eagle. And you can show that pretty convincingly. And therefore, the idea that there's some sort of proto-language floating around there is, in fact, extremely unlikely. And the reason why this matters so much, of course, is that we are unique in having our language. And once again, the assumption is that we have effectively a seamless continuum from animal grunts and howls to fully fledged language. And that strikes me as extremely improbable. Now, I don't have time, unfortunately, to unpack all this, but to begin with, what I should say, and I'll come back to this in a slide after next, I'm enormously influenced by one of the Inklings. Fred kindly mentioned him. This is Owen Barfield. Had a very, very different view as to what the origins of language were, which were crucially that it is effectively mythopoeic. And you can see immediately here that there is some sort of religious resonance. And of course, why this matters is that language is more than vocalizations in almost an infinite way, in as much as it's infinitely deep. And famously, we have this recursion. There's one tribe which doesn't show recursion, I know that. But for instance, this quote here from the American 19th century, the clergy know that I know that they do know. And all you've got to do is put in the commas, and it's perfectly straightforward. You can break it down straight away. And the point about this is, as with music and as with language and with mathematics, all of these are infinitely deep. These can take us into completely new worlds to which all other species are permanently and irrevocably blind. And that's why I mentioned Barfield. Barfield had a huge influence on Tolkien, of whom I'm a great and an unabashed fan, and also, of course, with regard to The Lord of the Rings, which I myself regard as one of the most extraordinary works which I've ever read. It's absolutely astonishing. So that's all fine and large. Time is moving on. So here we are, teaching, enjoying music, and all the rest of it. And the caption then goes with this species, us. We are unique in many perspectives, even though we're clearly the product of evolution. And the caption is, what other species would think this is a sensible thing to do? We are, in sort of English, we are absolutely bonkers. We are extremely peculiar. And one book some of you may have come across. Now, I wouldn't normally show a book with this title in a scientific conference. It would be a death sentence. It's written by an Australian philosopher, now dead, unfortunately. He drank too much and he smoked, silly boy, David Stove. And when it says Darwinian fairy tales, in a nutshell, he says, as a philosopher, I have no problem with us being descended from these chaps in the case behind, no problem at all. But if you're going to try and persuade me that the sort of mental attributes of these apes, let alone anything else, can be transformed into the human, you've got to forget it. And he has many arguments for this, but what impresses me about him is not only that he writes extremely well, he's deeply politically incorrect, I recommend him for that reason as well, but also because he was an atheist. He was an expert on Hume. He didn't have any truck with Christianity, let alone any other religion. He wasn't trying to smuggle something in. He just said, as a philosopher, these things don't really add up. So what's next? Where do we go from here? Well, now this is where it again becomes interesting. Because, as I mentioned earlier on, with regards to evolutionary convergence, there should be many, many planets which in principle have human-like intelligences. And indeed, and this is something which you hardly need reminding, the tally of planets, exosolar systems being discovered recently, especially through the Kepler mission, is really extraordinary. And certainly many of these planets will not be habitable, but on the other hand, we have good reason to think that there are millions, if not billions, of Earth-like planets in this galaxy alone. But the problem is, as David Brin said, it seems to be terribly quiet out there. No trace of anything. No archaeological artifacts. Nothing in the fossil record. What on earth is going on? And it's perhaps because we just got to build spaceships and go and look. And I like this particular reconstruction of alien life because you can see here we're on a moon. This is a gas giant. You can just see another moon over there. And we're on a low-gravity planet. And the artist here has done his level best, or his or her, I don't know, to create something alien. But I, as a biologist, can see straight away where all this thinking is coming from. And although I didn't mention it previously, for example, the way in which a cockroach walks, a roach you people call them, you have hotels for them, yes, that's right, I remember. The way a cockroach walks across the floor is basically identical to the way a dog does in terms of locomotion, biodynamics, and also the nervous systems. So you may have a genuinely alien world, but evolutionary convergence would persuade me that the differences are pretty superficial. Would you want to meet any aliens? Well, here's a cautionary tale, very quickly. Inasmuch, of course, there are many social systems on this planet, and the fossil record of the bees in particular shows that there were many extinct varieties which had somewhat different social arrangements. But today we effectively have amongst the complex eusocial bees only the stingless bees and the honey bees. All the other ones seem to have been driven to extinction. In the paper describing this, the authors said, well, that's very interesting, you know. I can think of another species which has also perhaps driven many other species to extinction by competitive exclusion, because it too is highly social. It too collects resources, it too defends its nests, it too sleeps, it too might even dream. And this is not a comfortable photograph for you people in this country, I realise, but the point is that it's not automatically clear to me that if we were to make contacts with aliens, they would necessarily be well disposed towards us. So as I've said many times in the past, if the telephone rings, just say we're busy, or we'll call them back. Something, your call is important to us, and all that sort of rubbish. Yep. So I think that what has been referred to as the Fermi Paradox has really coming back to haunt us, because not only is it the sheer number of extrasolar planets, but also it's clear that many of these solar systems, in terms of their initiation, far, far predate our solar system by billions of years. So in principle, they should have a head start of 1, 2, even 3 billion years. So Enrico Fermi, shown here, of course, came to this country, fleeing Mussolini's Italy. In that famous conversation in Los Alamos, said, "Where are they? What's going on?" Well, there are plenty of solutions. I've just picked up a copy of Stephen Webb's book on the Fermi Paradox. In his first book, I think he had 44 explanations. In the new edition, he's got 75. So you'll be pleased to hear I'm not going to go through those. I'll just very quickly mention. And the most obvious and most likely, as scientists, is we've just not looked hard enough. You don't just point a radio telescope at the sky and sort of say, hello. It's much, much more difficult than that. But I'm not sure that's necessarily the explanation. Another possibility is that we could actually detect extraterrestrials at great distances, and many of you will be familiar with this concept of the so-called Dyson sphere, whereby a civilization traps the radiant energy from a sun, and in doing so leaks it as infrared radiation, and thereby to an astronomer would be an anomalous source. Nothing has been detected which would be consistent with a Dyson sphere. There have been one or two claims, but more importantly, I think, is that those very advanced civilizations, the Kardashev Type 3 as they're often referred to, could in principle harness the whole of a galaxy. And it turns out, in fact, that people did a survey of infrared galaxies, and indeed they did 30,000 galaxies. That's a big number. And they didn't find a handful of potential infrared sources which were anomalous and could potentially be equivalent to this. But every single one of those turned on closer investigation to almost certainly have a natural explanation. And the reason why this leaves me sort of slightly nervous is that even if it didn't happen on this galaxy, then surely in the multitude of galaxies, one would eventually see something like this. No sign at the moment at all. Now, another joke, of course, is that supposing we do get a signal, it might very amusingly be that actually we don't understand a word they're saying. This upper one is the famous Voynich manuscript, which some people have recently claimed does have an explanation. It's a 15th century manuscript, and it resembles a sort of herbal, but the writing here is totally and utterly unintelligible. Nobody has any idea what it's saying. Beneath here is the script, I'm told, from Easter Island, Rongo Rongo, and again, nobody, I believe, has deciphered this. This probably says 2 pints of milk, and could you put the cat out, please? There we are. Yeah, who knows? But it's this question that we will assume that they will be mathematical. We will assume that they will use something like prime numbers and so forth. But it is possible that, in fact, even we made contact with them, we wouldn't have the foggiest idea what they're talking about. And linked to that, which goes almost full circle to what I was saying earlier, is, of course, the possibility that, in fact, yes, animals evolve all over the universe, but all they do is hunt, growl, purr, and roar at each other. For whatever reason, advanced intelligence never transforms itself into human intelligence. Other explanations, very quickly, is maybe the origin of life itself is an absolute fluke. It's a possibility. Most people think that's less likely. Considerable advances being made, some of them in Cambridge as it happens, but that is a potential bottleneck through which everything has to go. Or perhaps galaxies are sterilized by gamma rays. And because the intensity of these gamma rays is decreasing through time, anybody living within the oceans would be safe, but anything which is terrestrial gets fried. And so if indeed across the universe, everywhere where these gamma rays are generally becoming less dangerous, then all across the universe, there are people called Fermi just about now standing up saying, that's funny, where is everybody? Maybe there are, maybe there are phase shifts in the universe. But, and I need to be careful here. You know it's dry universe. You know this is a dry campus. I know this is water, but it tastes very much like Tanqueray. Be that as it may. Excuse me. Here you are. You considerable expense. You very kindly brought me here, and I'm actually going to give you the answer. You sitting down? Good. That's a relief. Terribly sorry about this. I do apologise. You don't exist. I'm sorry. There we go. Yep, you're right. We live in a virtual universe. Yep. Oh, yeah. Just the way it turned out. Sorry about it. And this idea is so mad, it might just be true. I don't think it is for various reasons, but there's a chap called Stephen Baxter who has explored this possibility and effectively said, what is the size of the universe? So when Galileo saw the moons of Jupiter from Padua, they were virtual. Because when we send a probe there, they have to become real, and so the story goes on. But I think the point about the Fermi Paradox, and in a sort of way human intelligence as well, is we've really got to start thinking out of the box in this area. And in a funny sort of way, we're sometimes quite good at that. And this all goes sort of full circle to, in a sense, not the same question, but a linked question. And that is something where I think we really have hit the buffers at the moment, and that is, although this would not be agreed by my materialist colleagues, what is the nature of our consciousness? Here we are with a brain which is larger but otherwise identical to an ape. What is it about us which allows us to have these mental capacities? And one way of looking at it, there are several, is to argue that in a sense our brains are, and this is a metaphor really, they're more like a filter. The mind isn't actually made in this brain, it's filtering something which is, if you like, universal. And you can look at this in a rather unhelpful pantheistic way, I'm not suggesting that. But the notion, in a way analogous to mathematics, is that we access these things, we discover them, and that way we understand them. Necessarily you have the organ to do it, but that's only part of the story. Now, I'll very quickly finish by telling you a couple of stories to, from my perspective at any rate, just to suggest that things are even more complicated. This is a book I came across some years ago. I believe he works in Chicago, Jeff Kripal, and as you can see it's called Authors of the Impossible, the Paranormal and the Sacred. Well, here's another area to engage in career suicide, the paranormal. What is he talking about? Well, I wouldn't necessarily say many of you have had, but I know some of you will have had what would otherwise be regarded as quite uncanny experiences. Really strange things happen, infrequently by and large. And I'm going to, there we are, we'll finish with this one here. I could give you two others, but this one will do fine. This is one very well-known story. It's 1918. Oh, actually, hang on a minute, let me go back. Sorry, I need that one first. It's 1918. This is a ship on the Royal Navy off West African coast on the African station. And this is Harold Owen here. He's not very well, he's got malaria. But then, to his surprise, in his cabin, and some of you will know this story, of course, there appears to him, someone he knows rather well, his brother, Wilfred Owen, the famous war poet. And Harold Owen immediately understood that his brother was dead. He didn't have any shadow about this. And he writes about it in two separate places, but he insists that his brother was there. Now, you can say, well, he had malaria, he was worried about his brother who was in the trenches, it was just before the end of the First World War. There are plenty of natural explanations, if you like, but that, just as one vignette, is a sort of indication that perhaps, again, we're dealing with unfinished business. I don't know really what this means, and I could give another story, and I won't. This is one taken from G.K. Chesterton's Father O'Connor. But now at this stage, because I think I've kept you going for far too long and all the rest of it, I'm just going to finish, actually, if I may so, on a slightly Brexit note. That's my favourite aircraft, the Spitfire. And to thank you very much indeed for listening to me so patiently. Thank you very much indeed. Thanks. Thank you. Yeah.
At this point, Dr. Morris will take questions from the audience. So you guys will see we have a couple microphones set up in either aisle. So if you have a question, please step up to the microphone and you can ask Dr. Morris.
Hi. So I'm sorry if this is a question you get asked all the time.
Oh, 6th of November 1951. Sorry, oh no, sorry.
Well, okay. So, putting aside a naive, literal reading of Genesis, Christians are nonetheless obligated to take the theology of the Bible seriously. How do you reconcile the theological principle that maladaptation, disease, strife, suffering, and death, that is the effects of sin, entered the world at a particular moment in history, with the scientific principle that all of these strife, maladaptation, disease, suffering, and death appear to be deeply woven into the fabric of the cosmos?
No, thank you. It's a very important question, as you know, to do effectively with theodicy. I don't have an answer. It's a simple thing. It's a question often asked to me, very reasonably. I think one approach, and I was talking to some of the students at lunchtime about this, and this sounds evasive, but it may be one way one can begin to unpack it, is that I don't doubt that animals suffer, and I've no reason to think that trilobites didn't suffer either. It's not even clear you need a nervous system to suffer. In fact, that's quite likely you don't. But from one perspective, it only means something to us. We're the only people who understand it, if you like. I mean, I'm not saying, when a dog howls and so forth, of course it's suffering pain. But we're the only ones who put it, if you like, into a wider perspective. Now, that's not a particularly helpful thing to say, other than certainly thank goodness for anesthetics, as I know from my dental treatment. Oh, boy, quite so. And I think that way, beyond that, you can't go, other than in a way, if one is going to be theological, one has to be absolutely realistic about evil. Absolutely, it's a non-negotiable fact. Whereas in many societies today, it's put down to, bad potty training or, whatever, or not enough television, I don't know, something like that. Whereas, especially in European history, but there are many other examples there, what I find so astonishing is how that whole continent collapsed in the way it did from really about 1930 onwards. And there's you get this sort of train crash feeling. If you see the films, you keep it like that, one of the stormtroopers in Czechoslovakia. So I don't have an explanation for this at all. But it seems to me that, first of all, we are the only species which in a way can even begin to understand this problem. And that's not going to help us very much. And the other one is very unhelpful, but we are dealing with unfinished business. And what I think in a certain way the complaint is sort of almost redounded on us, because I'm obviously closer to my death than I was 67 years ago. But irrespective of what tragedies you might have in your own life, you're going to go through your own existentialist loneliness when you're dying. And this I find deeply objectionable. I don't want this to happen, but I know it's going to, and so forth. And in that sense, again, because one says, we have no idea what goes beyond that, there are many suggestions and so forth, but you are taking a complete leap in the dark, utter leap in the dark. You hope it's going to be all right. We don't know, or it may not be all right at all. There are a few hints to suggest sometimes it definitely is not all right. And so in that way, we are working our way into a framework which has a future potential. And that's all I can really say. I mean, I'm not a good preacher, whatever. I don't have any consolation. We all know people who've been struck down tragically young. And it's, you just want to rage against it, obviously. Yeah, that's all I can honestly say. I mean, I take your question to the heart, but I can't take it any further.
Thank you, I appreciate that.
No, thank you.
I'd like to know what it is about your vaporized lemonade that causes fruit flies to do that kind of thing.
Oh, that's simple. You just need a bit of tonic. Oh, no, sorry. It's a different question. How stupid. Okay. The reason is effectively because the fruit flies live on fruit. Fruit ferments, and therefore they have to have alcohol tolerance. That's basically the story. Well, I mean, just to amplify that slightly, there are two things, one of which should worry me, or maybe two things actually. First of all, if you keep on repeating the experiment with the same fruit flies, they get used to the alcohol dose, so you have to up it. So when I was quite young, I used to come to this country working in the Smithsonian, and I have a gin and tonic, about where you can't see from where you are just well, really quite small. These days it's got to be sort of half a tumbler to actually work. And the second thing is, in fact, and you didn't hear it from me. This is being censored. Could you turn it off? Thank you. Is that if you look at the female fruit flies, actually they're not so good with the booze as the blokes are. So make of that what you will. That's a fruit fly, not a human. Sorry. Yeah.
Maybe I can ask the question I wanted to ask. I was just joking, but thank you. I appreciate that. So if I understand you right, you have a certain probabilities that you calculate, and then you go on to say, given that these probabilities are quite high for universal life, even human-like life, then I need to solve the Fermi Paradox. If you go backwards on that, the probability calculations that you do, I don't know how you do them.
Me neither. Yeah.
So the question is, do those probability calculations have doubt in them to the extent in which life might be so pervasive?
Well, with respect, I mean, it's an impossible question. It's just that my view of it, and I'm halfway through Stephen Webb's second edition, is that clearly one signal, one archaeological remnant, everything changes. So I'm writing a chapter on this, and as and when the book is published, the day after it could be completely out of date. But my sense at the moment is that something doesn't add up here at all. And in fact, what I think it is that our future is not what we think it's going to be. And I'm not trying to read this into an eschatological thing, necessarily, but it is that actually that example I gave you of Harold Owen and his brother Wilfred Owen is that it's pretty clear to me that for a whole set of reasons, that there are a whole set of, for want of a better word, this is not a scientific statement, it's just reading quite widely, I suppose. There are a whole series of orthogonal realities, and every now and again they impinge on each other, and these things happen. And that, if you like, is a hint that, you know, the world we live in, although we treat it as a sort of three-dimensional, we know about relativity and those sorts of things, but there's actually a whole, sorry, it sounds rather mystical, and I don't mean it that way, it's a whole hidden aspect to the world around us. And this explains these otherwise totally unaccountable stories. And that's, I think, where the answer lies. Thank you.
Hi. You stated that the mind works as a filter. And in the book of Genesis, it states that God breathed the breath of life into man. And that's where man's spirit came from. So my question is whether you're working with the Big Bang Theory or whether someone believes that God set evolution into on its track, how do you work the concept of a spirit into that? Where does the spirit come from?
Peter, you never told me the questions were going to be so difficult. I had a firm understanding from the organisers. They'd all be easy. No, I think the thing there would be, and again, I was talking a bit about this. This is not going to. Now, you notice the Cambridge academic. He does not answer the question. Well done. We're very well trained. But I think this might be relevant. I mean, I don't have an answer per se, but that word spirit, I don't know the Hebrew for it, I'm afraid, but I should. But in Greek it's pneuma. And as Owen Barfield pointed out in his various books on the origins and development of language, initially pneuma means everything from breath to spirit. They are indissolubly linked. And the reason he thinks this is important is twofold. First of all, because as time goes on, we fragment our language into what is actually referred to by Flieger in her book about Tolkien as splintered light. And that's why science is so successful, because we use extremely precise terms in extremely restricted areas. But the other thing is that, as Barfield would claim, and I think he's onto something here, actually, as our language changes, so does our consciousness. So what one would want to try and do is put oneself into the mind of an 8th BC Babylonian Jew, because that would be the first step in trying to understand what is meant by breathing a spirit into a human. So and if you then come to me as a sort of scientist or even as a historian and try to say, well, you know, how are we going to put these things together? Does this have anything to do with suggestions about the mind being a filter? There's presumably some sort of connection. And again, I'm not rubbishing what you're trying to say, very much the reverse, but the question doesn't quite lie there. And so correspondingly, when people are arguing for some degree of concordism between the Genesis narratives of creation and, say, geological history, or whatever, I think this is, quite frankly, a waste of time. What the Genesis narratives are telling us is a particular relationship between a people and the person they saw as being unlike any other god in the region. That's what really matters, yeah. So, is that?
So regardless of whether or not God exists.
He does, don't worry about that. That's
I'm a Christian, but putting that aside, do you think humans do have a spirit and animals do not? Or is there something that goes on purely biological in the mind, in its development?
I don't know the answer to that at all. What I think it is more, again, it's as mentioning to the other questioner, it's more that we're dealing with unfinished business. Okay, I mean, there's this very famous quote in Paul about the whole universe. I mean, it depends what you mean, what he thought about universe, sort of groaning to become to something else. And I'm sure animals have a spirit of a sort. I say they have emotions, they have attitudes, they have personalities, and in that sense, I would say, yes, they have a spirit. Are they immortal? I don't know. I have no idea at all. Are there dogs in heaven? I hope so. Are there cats in heaven? I hope not. Oh, no.
Thank you. We'll move on to the question behind
Sure.
you. And then
Yeah, thank you very much.
My question is similar to hers, but how would you square the filter approach to consciousness with your readings of the soul in theology? And if our minds do act as a filter, and that's what our minds are, then what part of us can be said to go to heaven when we die?
Well, I'm sort of fairly orthodox here, I'm afraid. It is that the resurrection, which we all pray for, hope for, of course, is bodily. So whatever happens, I mean, whether I'm cremated or buried and so forth, in a certain sense is an irrelevance. But my own view, I'll let you know, by the way, my own view is, in point of fact, no, that we're not sort of disembodied spirits wandering around with spare wings on our back or something like that. I think it'll be a sort of Middle Earth, but it will be far larger than the Middle Earth we know. Well, you remember the end of the Narnia story, probably, you know, the last battle. If you're not, I recommend it to you.
So, but how would you reconcile that with a lot of Christian thought? Because it does seem that it has a very dualist flavor to it, and it sounds like that's not necessarily a dualist position.
No, I wouldn't want to be a dualist per se. I mean, you know, for what it's worth, I think you know what we actually don't understand about the resurrection is our only clue as to what happens next. That's the only thing we know, and he was amongst us.
All right.
Yep.
Thank you.
Joe, you're most welcome.
Let's take one more question over here, and then we'll give Dr. Morris a break from speaking. Thank you.
So you were talking about great filters in the Fermi Paradoxes, and there were a couple of choose-your-own-adventure points that were very important we got past. From your studies of geological and paleontology type stuff, which one of those do you think is more important? So, how do I say this? For example, let's say we have 1 billion planets and they all start off with like the exact same cells that hold running through the tape. Are most of them going to get caught up at the Cambrian explosion stage and, you know, all these planets get stuck without multicellular life, or, you know, we get stuck without mammals, or...
Sure.
Yeah, or especially the jump between the first hamster-sized mammals and us.
Yeah, it's a complicated question, of course, but in essence, there's a growing suspicion that the way planets evolve is very, very various, and it may be a variant of the so-called rare Earth hypothesis, that actually there are all sorts of peculiarities about this planet, things like plate tectonics and so forth, but on the other hand, the number of planets which are potentially habitable is so large. But I think overall, I mean, we could unpack this in lots of different ways, but for instance, if you think about the evolution of the nervous system, complicated as it is, and this is something which is universally true in biology or evolution, a good part of what you need to build a nervous system has evolved long, long before there was any nervous system anywhere. Not surprisingly, because it's to do with vesicle formation and all the rest of it. So these things are just co-opted in. And corresponding with your mammal example, and I didn't talk about it here, but it's something that interests me very much. The argument is the dinosaurs go extinct, that's our golden opportunity. Correct, but it wouldn't have made any long-term difference. Mammals were already diversifying in the time of the dinosaurs. So, in fact, even in the Cretaceous, it's not actually a particularly advanced mammal. It's a mammal about the size of a dog, which had baby dinosaurs for breakfast because they find them in the gut.
Yeah.
So mammals are already going on their way. So all things being equal, which is a dangerous thing to say, I would think that the starting points, as long as they're reasonably similar, are going to end up, in principle, with something like us. And that's why the Fermi Paradox is such a problem, I think.
So would you say it's reasonable that if that Cretaceous mass extinction didn't happen, you give those dinosaurs an extra 60 or 70 million years and they'll end up doing what we ended up doing?
No, unfortunately not. They'd end up in the larder. No, what mass extinctions do is basically they give you 50 million years for free. And I mean, of course, some dinosaurs evolved into birds, and crows and so forth are pretty impressive. In any case, that's one way of looking at it. But more particularly, more complex social groups which invent tools are an inevitability. And I don't really care whether they're a mammal or a bird. It's really totally unimportant. And sooner or later, they're going to look around and say, what's for dinner? Good question.
All right, thank you all for being such an engaged audience.
Thank you very much. Thank you.